Alrighty, we're gonna do learn cloud security by doing without screwing up with Zach Steinler from Duo.
Yeah, thank you. Thanks, everyone. It's always a little dangerous to talk right before lunch. We'll give it a shot, though. So at Duo, we write a lot of software. More often than not, that software is running in the cloud, usually Amazon Web Services. And we have a little bit of a dilemma. We have about 100 engineers. Some of them are security experts, but some of them aren't. Some of them are web application experts or database experts or machine learning experts. But everyone wants to run their software in the cloud. So how do we make it so that those people can learn about cloud security? They can build their app and safely deploy it to production without just shoving them right into production, because that would be very risky for the business. So I know this isn't the philosophy track, but bear with me for a second. Cast your mind back 10 years in the aftermath of the financial crisis. In Ann Arbor, we were trying to figure out how to develop more of a tech ecosystem. And we discovered that the Kauffman Foundation, sometimes called the Foundation for Entrepreneurship, had this really cool model called the Stairstep Model. So Kauffman's idea is a lot like a gap analysis or a risk assessment. They didn't say pick everyone off the street and make them run a tech company. They said look at your ecosystem, figure out where the gaps are on people's journeys to becoming entrepreneurs, and help fill those gaps. Well, can we do the same thing for teaching our coworkers about cloud security? What would those steps look like? I don't think the path is quite as cut and dried as this, but I want to go through and talk about what infrastructure we can build, what programs we can put into place to create kind of like an on-ramp so that people are able to learn cloud security over time. To do that, we're going to need a couple of different pieces. We're going to need a way to divide up our cloud accounts into production and everything else. We're going to need some security baseline controls in all of these accounts. We're going to need to figure out how to manage these pile of accounts that we just created. And we're going to need to figure out how to do monitoring of these accounts. Part of the idea here is that we want people to make mistakes in low-risk environments, but we need to know when those mistakes are being made so that we can work with them to fix those mistakes. Okay, I hate it when people steal jokes. This was not my joke originally. I searched for like an hour to try to figure out who came up with this original classification, but I could not find the source attribution. I'm sorry. So we probably have like 40 different AWS accounts at Duo, and you can take those 40 accounts and bucket them into different sorts of environments. Production is pretty cut and dried. That's where our services are running. That's where customer data is. But if we can't just dump people into production, we need to have other places for them to go along the way. And so this is the taxonomy that we've come up with. The sandbox is a place where it's a little bit of a Wild West. Basically, any engineer at Duo can access this environment. If they are evaluating a third-party vendor that they haven't yet gone through security vetting, that goes in the sandbox. If they want to play with all of the new features that just got announced at AWS reInvent, that goes in the sandbox. And because of that freedom, though, there are a few ground rules that we have to enforce. No customer data is ever allowed in this environment. It's never a good thing when a system is compromised, but if a system is going to be compromised, we want it to happen in the sandbox. And by firewalling that off from the rest of our infrastructure, by making sure that customer data, intellectual property isn't there, we're dramatically decreasing the risk when that compromise, or if that compromise happens. Once people have spent some time in that sandbox, once they've gotten familiar with the different features the cloud security provider offers, once they've gained some familiarity with security best practices, either through our training or their own experimentation, they're ready to graduate onto the development environment. Here, we still don't want people to have database exports of customer data, but maybe the customer data has been de-identified, or maybe it's been pseudo-anonymized. That would be a good thing for the development environments. We also ask that people start using infrastructure as code in the development environments. I cannot, oh man, I always say this wrong. I cannot overemphasize. I can't emphasize enough how important it is to have infrastructure as code. So as we're writing code, we make mistakes. I make a lot of mistakes while writing code. And we want to iron out those mistakes in the development environment. So by the time we're ready to do our production deploy, we're running a script that we've run, tens or hundreds of times in other environments. And we know that the firewall rules are going to be created correctly. We know there's going to be encryption between all the systems, that sort of thing. Also, if you are working with a third-party vendor and they've gone through your security assessments, hopefully they have some concept of test credentials that are separate from their production credentials. Developing and testing that integration in the development account is the right place to do that. And then finally, people have graduated and they're ready for production access. This is where we give them the with great power comes great responsibility talk. And we found that talk lands a lot better after people have been spending weeks or months using the cloud provider. They've probably already accidentally deleted their database. They've probably already accidentally spun up a Windows server that has RDP open to the world. But they did it in a lower risk account, and so the risk to the business is dramatically decreased. Even though those accounts are very different, they're also very much the same. So we take our same security baselining and apply it to all accounts, regardless of what classification they're in. You could argue that the monitoring and the security controls are even more important in the sandbox because we want to catch those early learning opportunities. That's where mistakes are kind of like most likely to happen. It's pretty basic stuff, doing the security baselining. There are lots of people who have written about baselining in AWS, also Google Cloud. I don't know that much about Azure, but if people have links, I would love to see that information as well. Maybe the only thing that's a little bit different and particular to AWS is this concept of an identity account. So as I mentioned earlier, we have about 40 AWS accounts, and we want to avoid people having individual human users and individual credentials for each of those 40 environments. That would become an offboarding nightmare. That also is an onboarding nightmare. And we want one place where we can see which environments teams have access to. So AWS has some tools to make this easy. All of the human accounts are in this one central place. There's no production services there. There's no infrastructure. And then from there, you can assume into these different environments. And then as someone progresses along their journey, you can add access to additional environments. And, especially for development and sandbox environments, you might be tempted to have just one for all of your teams. You can, but as more teams have wanted to experiment with like new AWS features, especially if it's something disruptive like networking, you can create multiple groups per team, and you can still manage them with a one identity account. Okay, so this is a little specific to AWS implementation, but I didn't want to just talk about ideas. I wanted to show some of behind the curtains how this works. This is using Amazon's IAM service, Identity and Access Management. So it has a concept of users. Those are your humans, your coworkers. Then you can put the users into groups that describe which accounts they have access to. That all happens in the identity account. And then in each of the other accounts, you create roles. So these roles have a trust relationship that say, yes, it's okay. This person can come from the identity account. They have MFA enabled. They have a session that lasts for an hour, that sort of thing. And you can attach policies to those roles. You can go as coarse or as fine-grained as you'd like. Oftentimes, people have very general policies starting out. But as you're maturing your cloud security program, it's a really good idea to scope these permissions and make more fine-grained roles that are specific to the actions that different teams are doing. Do the engineers really need access to provision a new database? Probably not. That's probably your operations team, maybe your DBA team. And so over time, figuring out how to segment those access controls is a really powerful way to increase the security of your accounts. As I mentioned earlier, infrastructure as code is mandatory for our engineers who are deploying production systems, but it's also really handy for your security teams. Initially, as we started creating these accounts, we had a little bit of like permissions telephone, where we would copy paste roles and policies from one account to another account. Not a good idea. You want to have one standard source of truth. It's in source control. People can do pull requests to request changes. And because it's in this one central place and it's standardized across our accounts, when we implement a new feature in our permission system and we want to roll it out across 40 accounts, that used to take like a week. Now it takes an afternoon or minutes if you hook it up to something like a continuous deployment system. So infrastructure as code is a really powerful way to take your sprawling infrastructure and tame it and standardize it across all these different environments. Okay, and then last but not least, I wanted to talk a little bit about our security pipeline. Again, a lot of the specific terms on here are specific to AWS, but there are equivalents to GCP. There's equivalents in Azure. Some additional research might be required. And maybe more than specifically kind of summarizing our existing workflow, think about like what are your sources of security data. Network flows, incredibly valuable. CloudTrail is how Amazon tells you what all API calls are being made, either in the web interface or via the command line, also very useful. GuardDuty is looking for anomalous network traffic. Auth logs, what systems are people authenticating to, when, from where. Web application firewall logs. These are all really valuable sources of information for your security teams. Because we have these sprawl of accounts, similar to the identity account, our security team has a AWS account where this information is aggregated. So you have to figure out like the plumbing. How are you going to collect this information from all these accounts and get them in one central place? Maybe the one plug that I'll make is that we're really big fans of StreamAlert. It's an open source project, I think by Airbnb, and it has a lot of built-in rules and good defaults for AWS security alerting. Not only that, but it's very easy for you to write your own security rules to have your own alerts on top of it. And so we found it very powerful, not just for its good defaults, but also for specific issues that we're interested in. A lot of times when we do incident response, the action items coming out of that are new stream alert rules so that we can detect even earlier when an issue is occurring in our environments. And then also important is that this process doesn't stop at alerting. Your incident response team, your security teams, you want them to be able to triage and do remediation without involving account owners, across the entire organization. So figuring out not just how to alert on the data, but how to query it, how to do that investigation. And even going as far as creating runbooks so that when a specific alert goes off, you say, go to the system, run this query, and using that to really increase the capabilities of your security operations teams. Okay, in the end, I'm not sure that the stair-step model is the right one. Netflix always talks about the paved path. I don't have a paved path. Maybe you all have a paved path, maybe not. It's a lot of work to make a paved path. It's more of like a garden ramble, I guess. So I've never found this progression to be linear, but we can create the desired path that we want our engineers to follow along. And when they join our organization, we can assess their skill level and kind of slot them into this process. So here's a hypothetical conversation between a new engineer and someone on the security team. The new engineer is in white and the security team's in green. Someone joins the team, they instantly get access to the sandbox. They start learning about, in our case, Amazon Web Services. They spin up an EC2 instance. Oh no, it was pwned. That's okay. We were able to detect it quickly with our monitoring pipeline. We were able to show them our infrastructure as code playbooks for provisioning hardware that's not open to the world. They spend some more time in the sandbox, and then they're ready to deploy a new service at Duo. So they need access to the development environments. We can go into an identity account. We can add that access. We can pair them up with a more senior engineer. They work on that for a couple of months, and then they're finally ready to deploy. And so this is a very different conversation we're having as opposed to, I'm new here, can I have access to production? that's a hard conversation to have. If you say, I joined 2 months ago, I've spent a month in the sandbox, I've been pairing with a senior engineer to provision my cloud infrastructure in the development environment, you can go take a look at it and make sure it's following security best practices. May I now have access to production? That's the conversation we want to have. Thank you. Any questions? Maybe I should keep my mic.
What do you see as the path there if you don't already have clean separation? Everything that's dev is off in one spot, everything that's prod is in another. Like, how do you push people to create the segmentation where you're starting from not that?
Yeah, I mean, so prioritization between delivering features to customers and security concerns is the eternal question, right? And maybe also, I used to work in a site reliability engineering role, so it's also like availability uptime. One way that we have found it helpful to help the organization prioritize is to attempt to quantify incident response risk. So you have a corpus of incident response data, hopefully, issues that you've seen in production, looking at how frequently that occurs, what the risk of the business is for this particular thing. Maybe it was like maybe an employee email list was leaked. Okay, that's pretty low. Maybe customer data was exposed. That'd be very high. And then using that to help the organization understand what the risks are they're facing. We have found that people outside the security organization are very receptive to that quantification. And you can't do everything all the time. But if you could say, like, here's our top 5 risks, let's pick one of these to address in the next 3 months. That's been a more fruitful conversation for us.
I want to pile on to the idea of infrastructure as code specifically for cloud environments.
Yes.
Because that is now like the first place that I go to look at a box instead of seeing like, what's this guy doing? How is this guy built? What should he be doing? And to see how an instance was spun up and provisioned and all the software was laid on it, that gives you a baseline of what should be there and what shouldn't be there, and what post-deployment activity is normal, should be abnormal. Not to mention, like, these are all the things that have been deployed by the pipeline, and everything else is a human being touching it.
Yeah. The danger, there's always a danger of the security department being the department of no. And so if you're like, here's our policies, it's in a Git repository. If you'd like to see a change, make a pull request so we can make a discussion. Like, okay, there's some people are like, pull request welcome. That's like aggressive. Figure out a way to phrase it better. Yeah. But both for the compliance team to see what policies exist in your environments, and for engineering teams to say, like, well, actually, we need this additional access. Here, I've looked up what the requisite rules are. That's a great way for security engineering teams to collaborate.
It's also a great way as a security person for you to learn the APIs of your cloud provider, and learn the business of CI/CD, and learn how that developer workflow works, so that you can join in on the conversation for how people work, instead of just coming to people with "you messed up" or
right.
"this is wrong" or "that's a bad idea." It helps you get into the mindset of how the business workflow works for deployments and feature releases and things and bug fixes, and that's the kind of workflow that you want to jump into.
Hi, Zach. Where do you start with all of this when you have no security team? Before I say the thing that I said at my last role every week, we are all the security team.
Yeah, it's tricky. So I think it's a hard answer, but a lot of times you have to even take another step back and say, okay, like just pretty much I approach every security problem the same way, which is like what's the problem space? What are the risks we face? What are the gaps in our current solution? And if there's no security team, or if you're the only person on the security team, it can be very frightening to be like, I need to take a week off of on-call in order to like develop a big picture plan. But I'm not sure. To me, it seems like it's required to do a little bit of an exploration of the problem space, see where the highest impact is, maybe see, your time is very limited, so what products out there can you leverage to sort of make this better? Google Cloud came much after Amazon Web Services. They have a much more robust concept of like role-based access control, and Google, of course, wants to be your identity provider. And so, and I don't know if you have the ability to sort of point the team in that direction, but maybe trying to find an environment where more security problems are solved by default. Amazon does a great job attempting to address security problems, but also the era that it was created in, a lot of assumptions about the threat landscape have changed since then. So I think there's maybe more security tooling required depending on your cloud environment.
Anybody else? Okay, thank you very much.
Thank you.